Hello. Today we'll be talking about Section 7.8, Applications of Exponential Functions. And specifically, we'll be talking about compound interest. So, what is compound interest? Is it good? Is it bad? Well, that really just depends on if you are paying the interest or you earning the interest. So, what exactly is compound interest? Well, let's go back and think about what simple interest is. Simple interest is when you earn interest on an original value, or you could be paying it. But with compound interest, it refers to interest earned not only on the original value, but on the accumulated value of the account as well. So you interest on interest. So that's the whole idea of compounding. If you are putting money into an account and saving it, and you're getting interest on it, then compounding it is a really good thing for you. However, if you're paying for something like on a credit card, then you're going to end up paying interest on interest. All right, so let's look at some things here. We need to talk about the compound interest formula. And so the compound interest formula says A of t equals P times the quantity of 1 plus R divided by N, all raised to the NT power. So this A of t is the end amount that we're going to end up with, the final account value. Sometimes in business you hear it called the future value. P is the principal, which is our starting value. R is the interest rate. It's said as the annual percentage rate, and it's going to be written as a decimal. And then N is the number of times it's compounded in 1 year. So notice the N shows up in 2 different places on this formula. And that N depends on how many times it's being compounded. So if we look over here, we see if it says it's compounded annually, then N is 1, semi-annually 2, because that means twice a year, quarterly 4, monthly 12 times a year, weekly is 52, and daily is 365. So you'll be using those values in here depending on how it says it's being compounded. And then the last thing is T, and T is the time in years, and it always needs to be in years. All right, so let's take a look at this first example and see what we have here. If you invest $3,000 in an investment account paying 3% interest compounded quarterly, how much will the account be worth in 10 years? So we're investing $3,000. So that's the principal, or P. So up here I'm just going to write P equals 3,000. Now the account that you're investing pays 3% interest. So we want to write that as a decimal. So we're going to write it as R equals 0.03. Now be careful to not write that as 0.3 because that would be 30%. Compounded quarterly, so we can see that quarterly is 4 times a year. So our N equals 4, and then the time is in 10 years. And so we're just going to replace all of those numbers with the variables there. So 3,000 in place of P, 0.03 in place of R, 4 in place of N, and notice that 4 shows up in 2 places there, and then 10 goes in place of T. So if we start in our parentheses and we put into our calculator 0.03 divided by 4, and then add 1 to it, we'll get 1.0075. And then the exponent is 4 times 10, or 40. Of according to order of operations, I need to do my exponents next. So use your calculator and put in 1.0075 and raise that to the 40th power. You should get an approximate number as 1.3483486. But remember that number keeps going and going and going. But keep that number in your calculator, and then let's times it by 3,000. So that will give us 4,045.0458, and it keeps going and going and going. Well, we're dealing with money here, right? We're trying to figure out how much is going to end up in that account. And so we're going to round to the nearest cent, or to the hundredths place. So that would be right here. And 5 is big enough to round that next number up. So our answer for this, $4,045.05. And that would be your answer. So that's how much money would be in the account after 10 years if it's compounded quarterly at a 3% interest rate, and you started with $3,000 in the account.